Part 1, the Novice Class. Simplest amateur radio license exam of the Novice Class examination written portion exam consists of about 20 questions. Those that deal with the very basic amateur radio with the code testing require the sending and receiving the international Morse code at only 5 words per minute and 25 characters per minute. Novice Class was probably conceived to give those interested in the amateur radio a chance to operate while they're learning radio theory, technician operating practice rules, regulation, etc. Questions with the novice exam are not meant for those who had years of training experience. They are designed to those with minimum knowledge of the amateur of the radio. This enables those interested but have little technical knowledge to obtain an amateur radio license and enjoy the thrill of the worldwide two-radio communication. A novice license is only good for only 2 years and cannot be renewed during this period. Who hold the novice license and can operate with the amateur radio while studying a higher class exam experience can be gained operating procedure that can value assistance with the next exam. You'll find the code speed seems automatically increase as you use it more and more, and as you experiment with the building of your transmitting and receiving system, you can help acquire a certain amount of insight into those questions next FCC exam you'll take. But the first things first. Gets past the novice exam, so the technician. We can consider the technician general license. Getting the novice exam in the first part of the book. Example, the study questions will prepare with the novice FCC exam or set questions, however, considerably longer, more detailed those of the encountering the exam. You do not know for sure the exact questions you'll be asked, so we're going to prepare you for prepare you on the exam. The FCC exam covers 9 areas. The area of FCC rules, regulation, radio phenomena. 3, operating procedures. 4, emission characteristics. 5, electronic principles. 6, practical circuits. 7, critical components. 8, antennas and transmission lines. 9, communication practices. All of this is coupled to learn to send and receive Morse code. Seems like a formidable task to a novice, doesn't it? But the answer involves a little technical knowledge, a lot of good old common sense of learning the code at 5 words per minute, and surprisingly easy to most of us. So the novice class examination are administered with a volunteer examiner selected by the applicant. Examiners conduct the unsupervised examination, must be at least 21 years old with a hold the extra advanced or general class amateur radio operator license, and almost any ham will help you exam. The answers to the study questions are not brief and abrupt. The answer for the nature of the question requires such answers you'll find when studying the answer. If you understand how to answer similar questions, you'll know how to apply what you've learned, and it had simple questions, simple answers. You might be able to memorize them, and you may be able to pass the FCC exam, but would you learn much? Are you ready to study answers given in this study guide? You'll have much better chance of passing the FCC exam on the first try. Chapter 1, Basic Electronic Principles. So some who have never exposed the basic electronic words, volt, ohms, amperes, inductance, capacity, etc., seem to represent a branch of physical science that are far too sophisticated for the average person. At first glance, someone would wonder would tackle the formidable task of learning about electronics. You're just sitting hearing words and discouraging. But once into it, we find the terms of basic electronics are really not difficult to comprehend at all. Suppose you want to water to lawn, you got water your lawn with a garden hose. Turn the water on at the faucet, you find when the nozzle end of the hose is closed, so you know no water escapes through it. You can see the hose expanding slightly. Pressure builds up with the pressure as the hose is measured with pounds per square inch, and electricity pressure of the movement of the electrons instead of the water is measured in volts. If the open of the nozzle lists a small amount of water, example, the nozzle provides resistance to flow of water in electronics devices called resistors provide resistance for the flow of electronic. Amount of resistance is measured in ohms. A small number of ohms restricts the flow of electrons, less than a larger number of ohms. Twice as many electrons will flow through a 100 ohm resistor as through a 200 ohm resistor. We see with the resistor circuit that provides resistance flow of electrons, and the amount of the resistance is measured in term ohms. We're speaking about the flow of water or flow of electrons. The movement of flow of electrons is called the current. In electronics, current to its term measurement is known as amperes. As might suspect, the 3 basic terms of the related relations to Ohm's law. Of the Ohm law state with the current over the ampere will flow with the resistance of the 1 ohm under the pressure of 1 volt. Stated another way, current varies directly with the voltage applied, inversely with the resistance. In this chapter, you will learn many basic terms of electronics. You're sure to be asked about some of the FCC exams. Before you begin studying, however, look at the common symbols of the identifying circuit components, figure 1.1. Those most of the amateur radio work with this exemption of semiconductor components. components. Solid-state devices are shown in Figure 1-2, with exposed with the symbol shown in the figures of the frequently amateur radio, with a good idea to become familiar with each of them. Last question, section typical question prepared with the FCC novice class exam. 1-1. What is the standard color code for the resistor value? The standard system 4 bands are painted on the resistor shown in Figure 1-3. The color of the first band indicates the value of the first most significant digit. The color of the second band indicates the value of the second significant digit. Third color band represents the decimal multiplier with the first of which the first two digits must be multiplied to obtain the resistance of the resistor. The final band indicates the tolerance of the resistor. Colors used for the bands of the corresponding values shown in figure table 1-1. Using example colors shown in figure 1-3A, since red is the color of the first band, first significant digit is 2. The second band is blue, therefore the second significant figure is 6. The third band is orange, which indicates the number formed as a result of the reading of the first two bands is multiplied by 1,000. In this case, you have 26 times 1,100 ohms, or 26 times 100, 26,000 ohms. The last band indicates the tolerance. Alright, show that A is a resistor, B is a potentiometer, C a photoresistive cell, D a capacitor, E a capacitor, F a variable capacitor, G a variable capacitor, H a piezoelectric crystal, I electrical capacitor, J inductor, K turnable inductor, L turnable inductor, O M choke, N relay, O relay, SPST single volt switch, P voltage cell, Q R battery, AC source, S is AC source, T is a fuse, U is a monetary contact switch, V an antenna, W earth ground, X chassis ground, Y wire tie point, and Z a meter. And circle tells the function A ammeter, ammeter, and V for voltmeter. Is the color silver intolerance? If the color is its color is silver intolerance is 10%, of the allowed variation ohmic value will be shown at 23 to 400 or 28 600 ohms. What do you do with letters like V, I, R, E, E, H, F, W, and J represent? V equals volts, I equals current over amperes, R resistance in ohms, E electric motive force in volts, H inductance in henries, F in capacitance in farad. Shows A is a negative polar bipolar switch, B light activated silicon rectifier, C diode, D variable varactor tuning diode, E resistor, silicon controlled rectifier, F triag bilateral silicon rectifier, L light emitting diode, G light emitting diode, H P channel field emission transistor, I unijection transistor, J Zener diode, Z K diact bilateral trigger, L photodiode, M light activated negative polar transistor, N photodiode, O tunnel diode, P pulse snap diode, Q tunnel diode, S reactor, T positive negative bipolar transistor, U photo transistor, Z Zener diode. Alright, show the resistor color code. Black is significant 0, decimal multiplier 1, percentage positive negative, brown 1, significant figure 10 multiplier, red significant figure 2, decimal multiplier 100, orange 3, 1000, yellow 4, 10,000, green 5, 100,000, blue 6, 1 million, V or so violet significant figure 7, 10 million, gray significant figure 8, 100 million, and white 9, Significant figure 9, 1 billion. Gold is a tenth of a decimal multiplier. Resistance tolerance is 5. Silver is a decimal multiplier of 100. Resistance tolerance 10. No color. Resistance tolerance 20. W stands for watts. J stands for volts. 1-3. What is a volt? The term volt is unique electronic motor force, electrical pressure. 1 volt is the pressure required to send 1 ampere current through the resistor of the 1 ohm. We have red for a significant digit is 2. Blue is the second significant 6, which is orange is the decimal multiplier is 1,000, 26,000, and silver at 1/10. And then tolerance is 110. Tolerance per significant figure multiplier second significant figure by 1/4. By what expression of the difference of potential will describe the most common expression of voltage shown with the terms U the amperes, resistance drop, electric motive force, intensity, charge difference, charge pressure, electrical pressure, voltage drop, fall, potential. One finally, electromagnetic force. Every day, with the language of electrics, number of voltage between 2 points expressed with several different ways. Some of the area of voltage potential with the potential of the difference. Electromagnetic force, motive force. Strictly speaking, each of the terms indicate the quantities. However, they are quite frequently either interchangeable with the EMF. For example, should only be used referring to the force of which causes the move from the source of voltage. 1/6 method of connection should be used to obtain maximum no load output voltage from a group of similar cells in the storage battery. Connecting cells in a series increases voltage according to the number of cells connected, the total voltage being equal to the sum of the voltage of all the series connected. Connecting with them parallel increases the current capability, the total current capability being equal to the sum of the current delivering capabilities at each end of the cell. What is the sum of the voltage in and around simple DC series circuits, including the source voltage drop considered negative volts and the source of it considered the positive? The sum is 0. The voltage drops added together, subtracted with the source of voltage. The resultant will always be 0. In short, the sum of the drops must always be equal to the source of the voltage. Define the term resistance. Know the directed movement of an electron constant with the current flow. Know that electrons do not move freely through the conductor's crystalline structure. Some materials offer little opposition to current flow, which others greatly oppose current. The opposition to current flow is known as the resistance. And the unit measure ohm. The standard measure of the 1 ohm is the resistance provided in 0 degrees centigrade with a column of mercury having a cross-sectional area of 1 square millimeter length of 106.3 centimeters. A conductor with a 1 ohm resistance where applied potential 1 volt produces a current of 1 amperes. What is voltage drop? The electronic flow with a resistor gives up some of their energy with a form of heat. Heat is radiated with the surrounding area by the resistor. Further through the resistor, the electrons travel the more energy they lose. Upon reaching the end of the resistor, some of the original potential energy have been converted to heat energy. This loss of potential electrons travel through the resistor is called a full fall in potential or a voltage drop. What is an ohm? The term ohm is a unit measurement of the resistance. 1 ohm resistance will permit 1 ampere to current flow when a potential difference of 1 voltage is applied across resistance. The symbol representing the ohm is a Greek letter for omega. State the 3 mathematical forms of the Ohm's law. Voltage equals amps over the times resistance. Amps equals voltage over the resistance. Resistance equals voltage over amps. And the formula, therefore, difficult to remember. Memorizing figure 1-4 by covering the symbol of function of the need figure. With the other 2 symbols appear in the format that indicate whether to multiply or divide whether to E, electromagnetic force and volts, R, and resistance and ohms, and I, and the current of amperes. 12 is defined with the term ampere. The term ampere is a practical unit as current with the ampere will flow with the resistance 1 ohm with the difference of the potential 1 volt applied with cross or resistance. 113. What other expression may electronic current be described and made to describe the electron flow, electron mitigation? Ohm's law memory aid. Amps voltage equals amps over the resistance and ohms. Resistance and ohms is equal to volts over the amps. Amps is equal to volts over the resistance. What is the formula determining total resistance for all the resistors of the circuit in a series with a parallel of a formula determined with the resistance circuit with the resistors in series? Resistor total is equal to resistor 1, resistor 2 plus resistor 3 plus the resistor. The number of the formula determine the total resistance circuit when the resistors are all parallel. One is resistance total is equal to 1 over the resistor 1 plus 1 over the resistor 2 plus 1 over the resistor 3 plus 1 over the resistor 3 plus 1 to the resistor of the nth term. Define the term of electrical power. The power of the rating during the work of the work per unit time. Work result of the force action mass over the distance. Operational electronic circuit involves force of voltage acting on the mass electrons over the distance. Amount of time required to perform given the amount of work determined with the power extent with the express the equation of the relationship between power, work, and time. Power is equal to work over the time. E power is electrical watts, electrical power in watts. W is work in joules. Time is time in seconds. Since energy and capacity due to the work, power can also be defined with the time rating developed and expending energy. What is watt? Watt is a practical unit of electronic power if the power required to do the work rate at 1 joules per second in a direct current circuit. Power in watts equal to volts multiplied by amps. An alternating circuit with the true power to watts is effective volts multiplied by the circuit power factor. Therefore, 746 watts is 1 horsepower. Define the term joule. Joule is the unit of energy of the work. Absolute joule that is equal to 10 million EGRs. 1 joule is equal to 1 watt second. In field physical science, work is a product of the displacement force of the amount of work accomplished movement of the object can be calculated as work is equal work performed is equal to force applied by the direction of displacement times the distance through which the force acts. Since metric units over the force displacement distance and Newton meter respectively, work is measured in Newton meters. Newton meter has been named the joule. 1 work joule is done with a force of 1 Newton acts through over the distance of 1 meter. 1.8. What is the formula required figuring when the power of the DC circuit with the voltage resistance are known? Power is equal to the voltage squared divided by the resistance. So power is equal to the voltage squared divided by the resistance. What is the formula to determine the DC circuit when the current resistance are known? Power is equal to the current squared by the time resistance, or power is equal to amps squared times the resistance in ohms, with a formula to determine the DC circuit with the voltage current are known. Power voltage is multiplied by the current. Is voltage multiplied by the current, or power equal to voltage times the amps. If there are 110 watt and 500 ohm resistors connected with a parallel with a dissipation capability with a combination, resistant values have no bearing on the power dissipation rating. Each resistor can dissipate 10 watts of the total power dissipation capability per 20 watts. What will the dissipation in watts be of the 20 ohms resistor having a current of 0.25 amps? Power dissipation equals current squared times resistance, or the amperes times resistance, current squared in this case, 0.0625A. The figure multiplied by the 200 ohms equal to 1.25 watts. What would the minimum power dissipation rate with the 20,000 ohms connected in a current of 500 volt source? For ohms, we need another 20 kilowatt resistors connected to the cross of a 500 volt source at 0.25 amps or 25 milliamps. Power is equal to volt times the amplitude of the resistor required to dissipate at 12.5 watts. Most of the resistors are rated at 1/8, 1/4, 1/2, 2, 5, 10, 15, and 20. Nearest standard value above 12.5 is 15 watt with minimum value usable circuit. To allow possible change of the resistant voltage, it's usually wiser to use resistor and has wider safety margins, so the 15 watt would be minimum acceptable rating. The 20 watt resistor would be the best choice. Maximum current capacity of the resistor rated at 5 kilowatt, 5K 200 watts. Maximum current available to 288 milliamperes. Fully rated current. Current is equal to the square root of the power divided by the resistance. Amp is equal to the square root of power divided by the resistance. If the value of the resistance constant EMF is applied is halved, that will be the resultant proportional power dissipation. Applied voltage held the constant with the power inversely proportional. The resistance power is equal to voltage amps. The power is equal to voltage squared over the resistance ohm. The resistance decreases with the power dissipation, increases potentially with the resistance, increases power dissipation, decreases proportional resistance half, and the power dissipation is doubled. Defined with the term conductancy. Conductancy is reciprocal resistance and is used into the ability of material to support electron flow current. What is the unit conductancy? They should be easy to remember. Either bear in mind with the conductancy reciprocal over the resistor of the conductance is equal to 1 over the resistance of the basic unit over the Siemens unit is recently with the MHO or spelled backward. Signal purpose instrument may be used to measure electronic resistance, electronic current, motor force. Work sign purpose to prevent you from taking the easy way out of something like the volt millimeter or VOM, most of which does not measure power anyway, could hardly be considered a single purpose instrument. Here's what you do better prior to the exam. Meter measures resistance. Voltmeter measures electrical power. Meter measures resistance. Wattmeter electrical power. Ammeter measures current. Voltmeter electromotive force. What is the difference between the direct current and alternating current defined in each term? Electronic current is defined in the directed flow of current direction, electronic movement of the region, negative potential for the region, less negative potential for the more positive potential. Therefore, electronic current can be said to flow with a negative potential to a positive potential for the direction determined by the polarity of voltage source. Electronic current generally classified in two general: direct current, alternating current. Direct current flows continuously in the same direction, while the alternating current periodically reverses direction. What is the impedance unit of the measurement? Impedance Z is the AC equivalent of the DC resistance. Ohm is the unit of measurement. Impedance is the total opposition offered to flow in the alternating current. It must consist of a combination of resistance, inductance, reactance, and incapacitative reactance. Stated Ohm's law's AC circuit. It may be the same basic three forms. Ohm's law of DC circuit 7 with Z must be substituted for resistance. Voltage times amps is an impedance. Voltage equals amps times impedance. Amps equals voltage over the impedance. Impedance equals voltage over amps. Define term rectification. Transmission electronic energy with a greater distance was more economical through the use of alternating current. Alternating current must be transmitted over greater distance with a minimum power dissipation with a transmission line. Most electrons, many other electronic required of a steady source of DC voltage. Voltage must be provided to the DC generator. Changing AC to DC. Process of changing AC to DC is called rectification. The device used to accomplish rectification is called rectifiers. Define the term kilohertz or the megahertz. One or more important measurements associated with the light energy with the wavelength measurement of the light may be analyzed assuming they consist of waves similar to the ripples which are generated when the ball drops out into the pool. The waves for which are the generator consist of the number of cycles such as the crest, one over the wave, the crest of the next traveling, and the one crest name next to the wave has gone through with a possible variation number over the complete cycle per second called the frequency of the wave, which completes one cycle every 1/20 of a second with a frequency of 20 cycles per second. Frequencies are measured in cycles per second expressed in hertz. Perhaps prefixes attached to the word meter with the convenience with the expressive frequency 1 million cycles per second is to be used in frequency of 1 megahertz, 1,000 cycles per second, and frequency of 1 kilohertz of radio waves. In radio waves, these two terms are common terms to express frequency. 134, define term capacitancy. Two conductors separated by a non-conductor exhibit the property called capacitancy. Because the combination can be stored electrical charge. Inductancy property with the circuit with the opposed with the change of the current. Capacitancy is property of the circuit which opposed with the change in voltage. Where the inductancy stored energy is electromagnetic field. Capacitancy stores energy in electrostatic field. 135. Define term farad. Farad is unit of capacity. Capacity you have the capacity of 1 farad when a voltage changed from 1 volt per second across the produced one current of 1 amp. The farad is a basic unit capacity, too large amateur radio, but it's too large for amateur radio work. In radio, smaller units are used, such as microfarad, which are 1 millionth of a farad, and picofarad, which are 1 millionth of 1 millionth of a farad. With a formula what is the formula determining the total capacity of all the capacitors in a circuit are in a parallel? Formula determining the total capacity in a circuit with all the capacitors are a parallel. Capacitor total is equal to C1 plus C2 plus C3 to C to the nth term. Whereas the formula determines the total capacity of 3 or more capacitors connected in a series. Interestingly, the value of the capacitor series calculated exactly the way resistance parallels are calculated. The value of the equal to reciprocal sum of the individual value reciprocals, or 1 over capacitators total equals 1 over C1 plus 1 over C2 plus 1 over C3 to 1 over C4, which are define the term over coulomb. The coulomb is of the basic unit charged bodies over each other with a force of attraction. They are oppositely charged force of repulsion. When similarly charged, the force of attraction and repulsion changes with the magnitude change of the distance between them. Expression of mathematical relationship known as Coulomb's law. So you have the where Q1 and Q2 represent the charge, D is the distance between them. 1 coulomb is equal to the charge of 6.28 10 to the 18th electrons. Is also an electronic transfer of the current 1 amp per 1 second. Define the term inductancy. Inductancy is a characteristic electrical circuit that makes it evident with the opposing starting, stopping, changing the current flow. In other words, inductancy characteristic of an electrical conductor which opposes any kind of the change within the current flow with the difference capacity when it opposes any of the changes in voltage. What is the definition of Henry? Henry is a unit of inductance. Inductance is a circuit. 1 Henry is the current variation. 1 ampere per second includes 1 volt. Henry is a basic unit of inductance, but it's too large. Amateur radio smaller units such as millihenry, 1,000th of a Henry, and microhenry, 1 millionth of a Henry. What is the relation between the number of turns and the inductance of the coil? Inductance varies with the number of terms relation with it expressed in the equation. Inductance is where the n number of terms times the magnetic flux linking the coil produce the current amperes, multiplying result by 10 to the negative 10th, or yields independent inductance henries. 142. State a formula determining resonant frequency inductance capacity is known as, assuming the coil for the normal figure Q merit the formula of farad equals 1 over 2 times pi to the square root of inductancy times capacitancy. Explain how inductance produces transforming action. When a conductor placed in a magnetic field circuit which expand with the collapsing lines of force over the conductor, voltage will be induced. In this connection, consider coils 1 and 2, figure 1-5, placed side by side. Assuming the battery is connected with the coil 1 and galvanized and a galvanometer G with the instrument indicating the amount of the direction of the current flows and connected to coil 2. However, the change of variable resistance, there will be a change in the current 1 as a result of the flux through coil 2 will be changed. The galvanometer will show the momentary deflection action will change with the current with one coil induced and the voltage in another is called mutual induction. If in a short period of time the current coil 1 in figure 1-5 changes, causes a change in flux linking to coil 2, the voltage induced into coil 2 as the electromagnetic force of mutual induction, average value may be obtained mathematically. Even though coils 1 and 2 are close together, not all flux produced by coil 1 and links coil 2 proportion does link coil 2 to its inductive symbol K, called coefficient coupling, which is always less than unity. Flux in coil 1 is assumed with the proportional current in the coil. Flux and the change in flux with a proportion of the change of the current. Inductance coil may turn as many with a greater inductance coil. A single turn sensitivity inductance voltage dependent on only the change of the flux. The only number of turns through which flux passes. Inserting in an iron core coil generally greatly increases the inductancy. However, the increase is not consistent with one wide range of current. 2 coils that are placed close together, relation between the mutual inductancy M, 2 coils of the individual inductancy L1 and L2. The mutual inductancy is equal to the coefficients of the coupling over the square root of the inductancy coil 1 and times coil 2. The transfer energy for the one circuit to another mutual induction referred to transforming action. Whereas the magnetic field space surrounding magnetic with a magnetic force acts is known as the magnetic field. One method used to obtain with the knowledge pertaining to the magnetic field is explore with the field with a compass. By use of the compass characteristic magnetic field, various portions or points of the magnet may be observed. Figure 1-6 show the behavior of the compass. Thing with the compass used to explore compass needle and behavior in 1-6 field. About a simple bar magnet the compass needle aligns itself with the various position placed for the different points of the magnetic field with the alignment of the compass needle will indicate with the defined term line of the direction of magnetic field. 145. What is magnetic lines of force? Further to describe the work of magnetic phenomena, lights you the representative of the force at existing area surrounding a magnet. These lines, called the magnetic lines of force, do not actually exist in measuring lines illustrated to describe the pattern of magnetic lines. The magnetic lines of force assume that emanate from the north pole of the magnet, pass through the surrounding surface space, enter the south pole of the lines of force, travel inside of the magnet, south pole of the north pole, completing a closed loop. 146. What are the characteristic magnetic lines of force? So the characteristic magnetic line of force can be described as magnetic lines of force are continuous, will always form a closed loop. Magnetic lines of force will never cross one another. Parallel magnetic lines of force traveling in the same direction repel one another. Parallel magnetic lines of force traveling in opposite direction unite with each other in single lines traveling in the direction determine the magnetic poles creating the lines of the force. Magnetic line of force are shorten themselves, so therefore the magnetic lines forcing existing between two unique poles causes them to pull together. Magnetic lines force pass through all the materials, both magnetic and non-magnetic. Magnetic lines of force also always enter and leave the magnetic material at the right angles of the surface. 147. How is the or rested magnetic field intensity? Since the magnetic field is directly related to the magnetic force exerted by the field, the unit of the measuring field is, and certainly the word intensity is Oersted. One Oersted being equal to the strength of the necessary to exert one force of 1 dyne per unit pole. The relationship is expressed mathematically as H. Field intensity Oersted equals the force of action magnetic poles on the dynes over the strength of the magnetic pole unit poles. Define term Gilbert. Gilbert is a unit of magnetomotive force. Value of the magnomotive force over the Gilbert's magnetic circuit is equal to the line integral around circuits with the magnetic intensity 1 of the magnetic intensity expressed in Oersted lengthening being in centimeters. 1 Gilbert is equivalent to 0.7956 amp turns. However, the magnomotive force is measured with the region of the bar magnet where the influence can be felt by a call of the magnetic field. Magnetic field can then be pattern lines arranged in an orderly fashion, leaving the North Pole, entering the South Pole. As shown in Figure 1-7, a similar pattern magnetic field exists around the coil. Current flows through the coil, as shown in Figure 1-8. Strength of the field is called the magnomotive force, or MMF. Measured in Gilbert's proportional to the amp turns indicated in the formula. Magnomotive force is equal to 0.4 times the number of turns in a coil times amp current flowing through the coil through Gilbert's. 150. Explain how magnetic flux density clause in Maxwell. Total number of the maximum magnetic lines force leaving and entering the pole magnet is known as magnetic flux. Number of flux lines per unit is known as flux density. Relationship can be expressed as B, the Greek letter beta, representing flux density, over the Greek letter phi, representing total magnetic lines of force, and A, cross-sectional area. Most units measure the magnetic studies of the measure named to honor scientists who worked in magnetics. Unit flux density causes the unit magnetic flux from Maxwell equal to the one line magnetic force. Area is measured in square centimeters. The above mathematical equations show the proportional relation between the different units of the accurately used only with the uniform magnetic field of the field, which over each square centimeter contains exactly the same number of lines. The flux density of the magnetic field of the pole of the magnet can accurately be calculated given the equation. 151. Magnetic pole fluxes of 300,000 Maxwell with a cross-sectional area of magnetic pole of 50 square centimeters. Flux density and magnetic field at the pole is given at 300,000 Maxwell's area of 50 square centimeters. Shows the flux density of the Maxwells over the square centimeters would be 60 Gauss. Where the intensity of the magnetic field exerts over the 100 dynes magnetic having the strength of 50 unit poles. Given the 100 dynes over the 50 magnetic poles, or frequency of the H magnetic field is equal to 100 dynes over the unit 50 unit poles, or 2 Oersteds. Defining with the term characteristic impedance. Characteristic impedance with the surge impedance with the two generations, except for the definition. Most commonly, definitions state with the characteristic impedance with the ratio voltage current at every point along the transmission line with no standing wave. But the second definition states with the square root of the product of the open short circuit impedance of the line and circuits contained with inductor capacity with an inducting with the capacity pressure with the identified with the lumps and with the radio frequency transmission line. However, the quantity of the distributed through the entire line cannot be separated for each other. The characteristic impedance of the church impedance of the transmission line have the infinite length of the impedance of the ohms of the operating frequency with the pressure of the line with the source feeding with the line impedance across the input with the theoretically infinite line with a variable very valuable use. If the load is equal to the impedance connected with the output end of the line, regardless of the length of the line, with the impedance presented with the source of the input terminals of the line is still equal to characteristic impedance with the transmission line. Only way to value impedance particular type of size of the line acts in the way. The electromagnetic force will produce a current with 1 ampere through the resistance of an ohm is D, a volt. Chapter 2, Functions and Circuit Components.